All right. So we will have a look. We've had a look at what area is. So the area is the size of the surface that something makes up. So we're talking about the space in there. We measure it in squared units. So squared millimeters, squared centimeters, meters, or kilometers. So we talk about that being a square. So for example, a 1 by 1 square would be, if this is a centimeter by centimeter, we talk about that 1 square centimeter. If this is like a meter by meter, that would be 1 square meter. We always find the area by timesing the two lengths. We times two one-dimensional lengths together. So 3 centimeters by 2 centimeters. 3 by 2 will give you 6. And centimeter by centimeter will give you squared. So square centimeters. So that would actually look like this, where you've got 6 square centimeters. That's 1, 2, 3, 4, 5, 6 in there, and they're all 1 by 1. I know that's not square, but it should be. We always find that by timesing length by width, everything comes back to a rectangle. All the formulas have done that. If it's a 3D shape, we add all the areas from sides together. So we talk about the total surface area. We figure out the surface area and we total them all together. So we're going to look at some total surface area shapes and go through those and look at the formulas and why they work. So a couple of ones that we will look at is probably the easiest one would be a rectangular prism. So to figure out the total surface area of a rectangular prism, because it's a rectangle and you know it's a prism, it makes it pretty easy to calculate the area of this, the total surface area. So I'm going to write T.S.A, which stands for total surface area. So what would that equal? Well, really, all we've got to do, we can call this the width. We could call this the length if you want, and you can call this dimension the height. So the width here by the length here and the height there. It doesn't really matter what you call them, but what we can realize is if I go length by width, that is going to give me the area of this front shape, right? But that's also going to give me the area of this one because it's a rectangular prism. That means they're both going to be the same size. So I've got length by width plus length by width. So you've got two of them. Then you've also got your top pieces up here. And that would be your width, because that's the same one as that one, by your height. And then it would be the same as this bottom one, because that would also be width by height. So if you times those two, you're going to find the surface area of the bottom and the top Then you've also got the sides along here, which would be the height multiplied by the length. And that would also then give you this side here, which would be the height plus the length. So you can get them all together. You could also say, well, it's 2 lots of the length by the width, plus 2 lots of the width by the height, plus 2 lots of the height by the length. Can we factorize this? Yes, we can. They've got 2 all in common of them. So we've actually got 2 lots of the length by the width, plus the width by the height, plus the height by the length. So all you really need to do is just go length by width, figure out that, height by length, figure out that, width by height, figure out by that, and then multiply it by 2, because then you're going to double every side. So they're the formulas that you can do. You can do it in your head this way. You could just double each of them as you go through, or you could just do each one and then multiply it by 2 at the end. So if this was, for example, 4 centimeters, this was 3, and this was 6, you'd just be going, well, 3 by 4. Sorry, length by width would be, 3 by 4, plus we've got width by height, 3 by 6. Sorry, 4 by 6, plus height by length, which would be 6 by 3. And then you can solve that and get to it, and that will get you there. Okay, so that's where we can do it. You can use length, base, and you can also use length, base, and height. It really doesn't matter, whatever you want to call them. Length, base, and height is probably, you could use those. You can use length, width, and height. It doesn't matter. You'll probably see them interchangeably. Really, what you want to understand is that what you're calculating. As long as you understand where each of these come from, you're really calculating 6. If you think about this as a net, if I unfolded this, this is my base of this box. So that's the width and that's the height. You're really calculating each plane. this would then be, if I unfolded it, you'd have this flat, which we're referring to as this flat. That would be my height and my length. And let's bring this flat right over. We'll cut it along there. So we'll bring this flat back right over. It would also be my width would be along there, okay? And it's still the height along. So it's still the height along here. And then this flat would fold. Let's fold this flat out. So that would be width by length here. Sorry, whoops, that's not length there. Length would be here. And let's fold the back flap out. That would be width by length. Just like if you unpacked a cardboard box, and then we'd have the other length here. So you've got all of those ones there. So that would also be length. So that's what it is. You've got your 6 sides, and that's where we get it from. That's one of them. Another one, which you'll probably, and I know you guys know this, but we're just going to go through it, and it makes sense of what the formulas are. It's really a rectangle, because if you times this by this, you're counting how many squares are in there. Same with the other one. So let's look at a couple of other options. And we're also going to look at some other things that aren't in this chapter, just for you guys to understand. So we're going to look at a square-based pyramid. But I also want to look at a rectangular-based pyramid, just so you guys understand the difference between the formulas. Okay, so a square-based pyramid would, why do we call it a square-based pyramid? Well, it has a square on the bottom, right? We call it a square base because it's a square. That does not look square. Oh, come on, I can do this. Okay, a pyramid, the word pyramid, so that's my square base. The word pyramid means everything goes to a point up the top, every single side. So a cone is a special pyramid. I can call it a triangular based pyramid. What it means is that each point on the side of this will go to the very top. So this will go to the very top. This corner will go to the very top. Oh. This corner will go to the top. And this corner will go to the top. And even like, you know, it doesn't matter, even if I'm talking about edges, this edge goes to the very top. This whole edge, anywhere along this edge goes to the top. So that's what it is. So if I said like a rectangular base pyramid, I can call it a triangular based pyramid, but that would be a triangle on the bottom. So we draw a rectangular base. I don't like that triangle, that rectangle. We're going to draw a rectangular base, sorry. And every single point goes to the top. I don't like where that dot is. We'll make it up a bit higher. Oh, we'll make it lower, just so I'm not drawing along the same line. Okay, so I haven't drawn my rectangle quite right because you should be able to see both sides. But you get what I'm saying. So every point and every edge goes to the very top. How do we calculate total surface area of these? Well, this one, because it's a square based, right? That means all these are the same length. That means that we have a square. Let's call this the base. And let's think about this. Well, hopefully you should be able to figure out the formula just yourself. So if we know this is the base, and let's call this the slanted height, okay? So this, actually, I'm going to do this measurement here is the height. And that height makes a right angle right here. So it's going straight up to the apex of the top of the cone, of the top of the pyramid. So we know that this is the base. So the total surface area of this is going to be, well, it's going to be a square, right? Because the shape of it would be a square. And you're going to have 4 triangles. And all these triangles are going to be the same. These are all the same. They're all the same dimensions. I know they don't look the same, but this should be the same. They're all the same. So if that's the case, well, the square is just going to be base squared plus, well, if you think about what the base is, isn't it a triangle is half of a square? So really, it's going to be plus 2 lots of the base times the height. Now, you won't see this, but if you think about what a triangle is, I mean, if you've got a triangle this, you know that if you go, it's base times height, right? It's half of the base times height. But because you've got 2 of them same, base times height would give you, that would give you actually a whole area. So I can just say it's base squared times 2 times base times height. However, the book doesn't quite do it like that. I mean, well, it does. That's probably why. But another way I could say it is it's really equal to the base squared plus half of the, we've got 4 of the same ones, 4 of the triangles, which is the half base times height, okay, which simplifies to this. So that's how we get there. Alternatively, if it's a rectangular base pyramid, so we'd have to call this maybe the base, I'll probably call this the length and the width. And I would still have to figure out this perpendicular height, right? And that height would be here. Okay, if that's the case there, to figure out the total surface area of this would be, well, length by width would give you the bottom. Plus, you have different rectangles. So it would also then be by, and we can call this height 1. And let's call this one here, because this would be slightly different height. This one here, we're going to call this length height 2. Plus 1 lots of the length times height 1. Because there's half of a triangle here and half on the other side. So that would just give you a whole rectangle. Plus width by the second height, which is this height here, height 2. So notice that that would also give it to you. Now that would give you the total surface triangle. So hopefully you can see how these rectangular pyramids would work. Now we don't cover that, but it gives you a bit of an idea. One other shape I'm going to quickly go through, then I'm going to come back to this one, is just a triangular prism. So when we call the word prisms, we call it prism because it has the same cross section. So this is a triangle. And this triangle goes all the way through, like this section. Like, can you see there's still a triangle here and it's exactly the same shape? This triangle would be exactly the same shape as here, and it'd be exactly the same as the one on the end. We call it a rectangular prism because, well, there's a rectangle here at the front and it goes all the way through the side, or there, or from the bottom. So words prism and pyramid actually mean different ones. Where a pyramid comes from a prism. This could be a square-based prism, but a pyramid goes to the top. So when we've got this one is just figuring out obviously the rectangle area of this one, the rectangle area of this one, the rectangle area of the bottom, and the 2 triangles on the front and the back. So if we want to actually calculate that, we would need to figure out, let's just call this the width, call this the length, call this the height. So to get this, and you'd also need the slanted edge too. So let's call that S, right, for the slanted edge. So you've got to go, your slanted edge by your length would give you the front. So the total surface area, slanted edge by the length would give you, so if we unfolded this, it would look like this. This would be your width. That would be your length. This dimension here would be your height. And we'll pull the slanted edge off here. That would be a slanted edge. And that'd also be a triangle here. So the first thing we're doing is the slant edge by the length, which is this one here, which is the top face just on there, plus width by length, which is the bottom. Plus, don't forget, we also need to do the back edge, which is length by height by length. Whoops. Plus, which is this one here, we need to do the 2 triangles. So that's going to be the width by the height by a half, but you've got 2 of them. So it's just going to be width by height. And that would get you your area for that one. That is given that this is a right angle triangle. If it's not a right angle triangle, then you need to figure out what the actual height is of the apex, and then you can figure it out. Okay, going back to this square-based triangle, there are some interesting ones that make it a bit harder. So it will be pretty easy when you've got the slanted height. So for example, if you've got a question like this, okay, and let's just say this is let's go with this is 6 centimeters. This is 3 centimeters. Okay, the height, sorry, is 3 centimeters. I'm talking about the height, and that is a right angle. And then I ask you guys, and this is a square-based pyramid, what is the total surface area of this? Well, the total surface area would be, the bottom would be 6 by 6. So it'd be 6 squared, plus we also have 3 of the triangles, 6 by 3 by 2 of 6 by 3. So that would be the square on the bottom, 36, plus we've got 4 of the same triangles, so it's really 2 of the rectangles, 6 by 3, which is going to be 12 by 3, let's go 6 by 6, plus 36. So that would equal 72 centimeters squared. Now, another same question that I can get. I'm going to mix it up and make exactly the same triangle. I'm going to show you something. And this is where we can take it a bit trickier. If I give you a triangle, and again, you probably won't have too much of this in the book. I'm going to give you exactly the same triangle, except I'm going to change a measurement. Oh, that should be dotted. Again, this is a square-based pyramid. We know that the length of this is 6 centimeters. But this time, I'm going to give you this edge. I'm going to say that this edge here is 5 centimeters. How are you going to figure it out? Now, that you can't, because if you think about what this shape would be, the dimensions that you have is really saying this edge is 5. This is 6. Right? This is 5. This is 6. This is 6. This is 5. You with me? So this is where it gets a little bit different and a little bit tricky. So what we need to do here is if I went 6 by 5, well, this is a triangle, right? This is 6. This is 5. If you go 6 by 5, you're actually going to be figuring out the area of this, which goes up to about there. You're actually figuring out that. That is a 6 by 5. This area here is 30 centimeters squared. We don't want to know that 5. We want to know what this height is here. So hopefully what you can see is we can chop this out a bit. I can actually then go, hang on a moment. I know that that is 5. This is 3, right? Because I know that's going to come halfway between it. This is a right angle now, right? Because if you go halfway between it, it's going to make a right angle triangle. Now I can use Pythagoras' theorem. I want to find the shorter square. 5 squared minus 3 squared equals a squared. So 25, 9. The area of this has to be 16. The square root of 16 is 4. So therefore, you're going to find that that length is 4. So now I know that my actual slanted height is 4. And then we get back to, did I do that right? Yep, 4, which is not the same thing that I did here, but it's not the same question. I think I might have done that wrong. That's okay. So that's where you're going to get this one. So it's not the same question, but it's a similar concept. So sometimes if you're not given the actual perpendicular height to the base, and that's on the edge, right? So of this triangle, if you're not given the height of that triangle, you can't figure out the area. You sometimes need to use Pythagoras to figure out what it is. That will help you guys with some of the enrichment questions. So what I mean by that is, and you won't get these until you get to enrichment because it's a bit trickier. But I did just want to do it because I think it's really important to be on the ball and understand why it's different. So you'll notice that this question here is different because it's referring to 9 as your slanted edge, okay? Not the actual height of this one from the middle of it going upwards. So we need to be careful of that. This is things that get a bit trickier in like further maths, year 11, year 10, and so on. So just a bit wary of where the formulas come from. And that's it. The only other one that we have is what we're going to be moving on to next subchapter. And let's just go through that anyway, because why not? Is we're going to look at surface area of a cylinder. Now, if you think about what the area of a cylinder is, if you unwrap that, it would be like this with 2 circles. Now, the area of a circle and why it's pi r squared is because it actually makes a rectangle. If you take a circle, you take half of it and you cut this up into tiny, tiny strips. You get what I mean? And then you put it like this. Tiny, tiny strips. It's going to kind of make this teeth-like pattern. And these would all be the same height. Now, you know that if you did it really, really tiny, if you think about what that length is, well, the length from here to here would be the radius, right? Because you've chopped it from here to here. You just chopped it out. You're just cutting them up really small. That's a really bad circle. If it was a perfect circle, which is a bit better, you know, if you cut tiny, tiny strips out, I'm talking about making them really small and gluing them like and spacing them out, half of the circle you would build up like this. And the length of them would be radius because they'll be really small. This half, well, you could cut those up too. And then you could join it up, right, to go in here. So it would actually make a full pattern. Now, you know that this is the radius, this height. Now, what is the dimension of this? Well, that dimension, if you cut it really small, would be around here, right? Well, that would be half of the circumference. Well, what is the circumference of a full circle? It's 2 pi r is the full. Half of that, well, half of this, so from here to here, well, that would be only half of 2 pi r, so that's pi r. So therefore, this length would be pi r. This is a rectangle. If you made it really, really small, it would make a rectangle, right? So you times them. Pi r times r is pi r squared. And we made a circle into a rectangle. Every shape goes back into a rectangle. So that's why that one is pi r squared. So going back to this one, the surface area of the top, pi r squared, pi r squared. So the total surface area of this equals, you've got 2 circles, plus, right, plus we've got this area. What length is this? Well, that's the circumference of a circle. This is 2 pi r. And this is the height. Height. So all you need to know for this is the radius and the height. So you know that this is these two times each other. So plus 2 lots of pi r h. Now let me write that out. 2 pi r squared plus 2 pi r h. And while we've done algebra is now to make sense of how we can simplify this. Let's take out common factors. 2 is common in both of these. Pi is common in both of these. And r is common in both of these. Leaves me with r in this one. Leaves me with, I've taken out 2 pi r in this with h in this one. So I can write it like that, or I can write it like this. So what it really is, if you see it written like this, I prefer to write like that. It's 2 circles plus a rectangle. And it's the perimeter of or the circumference of a circle multiplied by the height. And that's how you find out the total surface area of a cylinder. Now, one thing you got to be careful of is if it says, oh, figure out the total surface area of this that I want to be painted, not including the base, you need to understand that that would be, well, then that would just be pi r squared, because it's just one of the circles, plus 2 pi rh. So it's the top plus one of those. So you've got to understand how it works. Now, if it didn't have a top or a bottom, and you wanted to know the total surface area of that shape, and it was just the outside of this, it would just be pi r, 2 pi rh. So you've got to understand how these formulas work. And that is both of the sub-chapters. Then it's just substituting in the numbers. So for example, if the radius was 3, you just put in 3. If the height was 10, you just put in height is 10 and equals that. So hopefully that's pretty helpful and it makes a bit of sense for you. So good luck. And that is where I'm going to leave it. Any questions at all?